Yo, what's up, everybody? Welcome back. Today, we are doing a little bit of graph theory. We are trying to merge a bunch of contours. Why, you might ask? Well, like 20 years ago, my dad gave me some monitors. I've been using them this whole time. Finally, they broke. So my second monitor wasn't really working for a little bit. I've actually solved this problem because I started sleeping on the floor, which means that I can take the monitor from my bedroom and that I used to use as a TV and put it on my desk. But I couldn't keep my Twitch chat on the second monitor anymore for a little bit, and so I was hiding it under my camera. The Twitch chat in the web view doesn't really handle being so small, like crammed in this little space here. It doesn't like that. So we start running our own Twitch chat client, which of course means we have to use our own GUI framework and our own text rendering engine. Sometimes people send us emojis, and so we try to render these emojis, and we render them incorrectly because our font engine's kind of dog shit. And one of the reasons that the font engine is dog shit is because of this, what we're looking at on the screen right now. So, fonts are composed of many contours, they call them. So, you might have like a Bezier curve, then a line, then like another line, then like another Bezier curve, and then another Bezier curve, or something. And then maybe you have like a line and a Bezier curve in here, and then another Bezier curve. And maybe this is how you construct something that resembles a backwards P. I don't know why I drew it that way, right? But like this is kind of what you might have. Maybe this is a bad example though. A better example would be something like the letter T, where maybe you have a box like this and a box like this, right? And if you take the outside of these boxes together, they create a letter, right? So the way that they kind of support both of these cases is they have the concept of winding order, right? So they have one contour here that's a circle, another one here that goes the other direction, another one here that goes the same direction, and then one here that inverts, right? So basically the rule is every time you are inside a clockwise circle or a clockwise contour, right, where that doesn't have to be a circle, but a circle is a very easy case to think about. Every time you go right, you add one. And every time you're in one that goes left, or clockwise and counterclockwise, you subtract one. And so the counts, if we were to sum up the counts of clockwise, counterclockwise, you might have something like this. So the outside, 0, right? Then we go inside this clockwise, so all of this stuff is 1. This is a counterclockwise one, so in this section we're at -1. And here, we are inside both the clockwise and counterclockwise sections. So this rounds out to 0, right? Here we go inside, so this whole section is 1, then we go back the other way, this is 0 again. And in here, we go clockwise again, so this becomes 2, right? Anytime we are inside, we add 1. Anytime we're in a clockwise, we add 1. Anytime we're in a counterclockwise, we subtract 1. And anywhere where the sum of these things adds to 0, we do not render, right? This is great. This is wonderful. And the way you can easily figure this out is basically you're for any pixel, you cast a ray to the right or any direction, really. You can cast this in any direction. And every time you cross a counterclockwise line, this is -1. And every time you pass a clockwise line, this is +1. And so you can kind of figure out your thing for each pixel by doing that. Okay. Our font rendering engine does something a little bit different here. Specifically, we do a bad job at rendering our fonts, right? So when you get really, really, really small, you end up with all of these aliasing issues where if you are not perfectly aligned with a pixel boundary, you're going to look kind of fucked up, right? And so fonts have all of these special rules for how you handle this. They have programs inside the font file that run through this interpreter that say oh, sometimes you move these things a little bit, just nudge them a little bit to the left or right so they line up with the pixel boundaries better and stuff like that. But we don't support any of that. Instead, what we do is we just kind of fuzz the edge a little bit. Right? We just make this edge a little bit fuzzy. And we do that by generating these things called distance fields. So basically for any point in a contour, we check, are we how far are we from an edge? So outside, here, we're 1 away, 2, 3 away, 4 away. And then inside, we're -1, -1, -1, -1, because each of these guys is kind of close to, any of these edges, we're like one away from here, one away from here, one away from here. And then as we get closer, these numbers like approach 0 as we get close to an edge. Now, why are we talking about all of this? Well, it turns out that what we are doing right now is dog shit stupid, and we are using these edges, which are not good, right? So that means that when we are trying to fuzz the edges, we actually consider this to be 0 distance from an edge. And so we will actually like do some fuzzing here as well when we shouldn't. We also like kind of do a bunch of, I think we have like some boundary cases wrong on our like raycasting logic to count our inside outside edges. But basically we can kind of solve multiple of these problems at once with like a little bit of like a, I'm not going to go into all the reasons, but we kind of want to generate the whole signed distance field on the GPU, which is doable by using like some like 3D geometry tricks. But we need to remove these inside edges. So today's goal is to figure out how do we remove inside edges, right? So there's a few cases to think about, right? There is, we could call this case the star case, where we have 2 clockwise sets or something, right? And so we kind of want this shape to turn into, I guess we can copy paste it. We want to turn this shape into this shape, right? So you take out all of these edges. So this is like 2 clockwise contours that are overlapping and create something that resembles this, right? That's case number 1. There is also a case where we have like a cutout, right? So we might have a case like this. How do I scroll in this fucking program? Okay. So we might have a case like this where we have a square and inside we have another square, and we'll call this case the O, right? So we start with one big thing. We have this little thing. Inside here is filled. Inside here is empty. Great. There's not actually any processing we have to do here, but we have to support this to some extent. There's also going to be a case that's maybe, we'll call it like the overlap, where maybe we have a square and another square like this, and we kind of want to turn this into something that looks a little bit more like this, right? So this is another case. And then one more would be what I will call like inversion, right? So we might have a square clockwise like this and counterclockwise like this, and we actually want to turn this into something where this is filled, this is empty, and this is filled, right? These are kind of a few of the cases. There's probably more, right? But these are the ones that I've kind of been thinking about right now, and like in terms of like how do I implement this. This is the same as the star case. It is very similar, except the winding order is opposite, right? So you're kind of right. There's very similar behavior between this case and this case. However, what the difference in terms of like my brain slot is that the vertexes here are inside each other. Right, so where here in the star case, all of the vertices are outside. So that basically means that we have to. This case reveals that we have to work with edges in some way. We can't just work with vertices. And then this case is different because it's like an inversion, right? So it is one cross here, but like, because one's going the other way, things might be a little different. So looking at all of these cases, I think I've come up with something sane. I think it will work. What I want to do is create. So we'll start with a star to present the idea, and I think that this idea will extend to all of the other cases, right? I think what I want to do is I want to make a graph where each of these vertices, we start with like all of the vertices that they give us, right? But then we will splice each of our edges such that there are vertices here and 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 here, right? Everywhere where 2 lines cross, we cut the edge and add another vertex. Then for each edge, we can do the like raycasting trick where we try to figure out what the winding order of each edge is, right? So here we go outwards, we don't find any crosses, so this edge has 0. This edge has 0. This edge will cross one thing on the way out, so this edge is 1, this crosses 1 on the way out, so this edge is 1. And basically, if we just kind of like do this, right, every edge where we cast outwards and we don't cross any lines is a 0. Anytime where we do cross is a 1, and we're gonna have to like count the clockwise, counterclockwise crosses to try to figure out if it's to like do the negative positive canceling out, so that we're on negative positive canceling out, so we like can identify which ones are a 0 edge, and then we just discard any edges in this like thing that are 0 are not 0 edges. So then, you know, once we've identified all of these, you know, it should be that we identify this edge as a goner, we should identify this edge as a goner, this one, this one, this one, this one, right? And this will be what we generate our distance field out of. I think that will work, but I don't really know, so we gotta try it. So the plan is, let's make some test cases and visualize them. Let's try to make this merged graph, identify inside outside, and then purge them. And then maybe it'll work. And then I guess there's probably gonna be like more testing. Probably something along these lines. And I think that that would be, you know, if we got to all that today, I'd be very happy with the progress for the day. So, let's get moving and grooving. I think we have a bunch of demo apps because we've been playing with a lot of stuff recently. But we will call this one, let's call it Contour Merging Demo. Let's call it that. And we are going to pull in our GUI framework, and we are going to make some sort of GUI that uses a custom widget probably. So let's edit source contour merging demo.zig. And let's kind of start with our GUI demo. I think that that is the place that is nice to start from. This guy needs to be a little bit, we need to adjust some imports. So he imports our standard library, and then all of these guys come from that. This is stud window, this is stud UI, this is stud util, and like this is stud math, and this is stud image. Okay. So if I build now, we should hopefully, we don't have this GIF, so we'll just delete that. Easy. All right. Zig out bin. Contour merging demo. Okay, here is a test GUI application. Perfect. Perfect. And let's just delete most of the stuff that we don't need. So I think that we are not going to need any GUI actions yet. He's not going to be able to request anything from us yet. We do not need this histogram. We do not need this other graph. We do not need a scrollable list. We are going to have a custom widget for rendering our visualization. We do not need to have a selectable list. We are going to create some allocators. Your windows are wobbly. Thank you. I agree. We are going to maybe make a square window a little bit. We are going to create some GUI state, and we are going to create some widgets out of that GUI state. Let's just delete anything that does not look like our custom widget section. A custom widget. Perfect. And then everything else in here, I think we can just kind of do like this. Let's see. All right, so this is our custom widget. Beautiful. And I think our custom widget does not need to do much. So what are we going to do? We are going to render some boxes. So let's make a box. And I guess we're going to have some sort of like contour, which is going to be a bunch of points. Right? Probably we will just work in OpenGL space for now, but maybe we are going to want to change that later. So this guy is going to be like, here is a contour. And this guy must take in an allocator then, because this thing is a slice. And we are going to allocate 4 of these guys. I guess technically we could not use a slice here and we could like give him an like an array back, but whatever. This is fine. So for each item in ret, we have some index. And we are going to actually, do we need to do this? Can we just like mem copy in? Maybe that's better. So we are going to have something like, let's put a square somewhere for now. So let's start with square 1, which is going to be like this. So we'll call this make box 1, and then we'll have make box 2 as well, which is going to be the diamond. Maybe make box and make diamond is what we'll call it. A diamond is technically just a box on its side, but, you know, shut the fuck up. You know? You know? You know? Okay, so this is going to have something like, if our OpenGL space is -1 down here, +1 over here on both axes, this is going to be -0.5 twice. And we are going clockwise. We don't really care about the order. We just have to be consistent. So this is -0.5, 0.5, right? Okay, yep. So this is positive. Then we have positive, positive, and then the one that's missing, which is positive, negative. This is our first contour. And then our second contour is basically the same thing, but it is what? All rotated on its side. So we probably want the same edge lengths, right? So this is going to be a 1, 1. Well, this whole width is 1 in this world, which means that this whole width is 1, which means that this is a 1, 1 root 2 triangle, but everything is multiplied by 0.5, so this is root 2 over 2, which means, oh, I guess it doesn't matter though, because we don't care about this length, we only care about our offsets here, so this is, wait, am I stupid? Yeah, okay, I am. This is not 1 here. This is 1, which means that this is 0.5, which means... No, that does not mean that. I'm an idiot. This is 0.5. Thank you. Okay, so we have this triangle, I guess, where I guess it's that this is a 1, 1, root 2 triangle. There it is. So this is root 2 over 2 to the right and root 2 over 2 up. Yep. So this is going to be stood math squirt 2 over 2. And then we are going to have, I guess, 0 and offset is our kind of thing. So we're going, let's start this one. So left, offs, up, 0. Then we go clockwise up to the right, which is 0 on the x-axis and offs on the y-axis. Then this is positive. So we just kind of invert these, right? So then it's positive and negative. All right. Cool. So let's make a diamond. So we'll use some allocator here. So we have a box, we have a diamond. Beautiful. Times cos 90. I know, but whatever. It's okay. It's okay. And our custom widget is today the day we'll see a correctly rendered A with this method. Maybe. Who knows? Who knows? And so this guy probably is going to want to look at those in some way, right? So we're going to be like, here is our box and diamond, right? So this guy is going to want to take in our contours, right? And for now, we will render those things. Except, well, yeah, we'll start here, and then we'll figure out how to adjust it later. So this guy is going to be some sort of program where he is going to probably create some vertex buffers out of these things. So I guess maybe he is going to what? He is going to render each contour. Let's just start with one, I guess, and then we'll figure it out. Okay, no, we can do a render lines. And so for each contour, we will spit out the lines that we are trying to render into the vertex buffer or something. Something like that. Something like that. So we are going to do something like vertex buffer is we want some sort of like scratch space to put this thing. Maybe just one of these. And I guess we know that if we were trying to make one line, we're gonna do something like contours total len num lines is 0. It's gonna start at 0. And for each contour, we are going to probably do something like take the contour length. So if there are 4 elements in here, there are also 4 lines because they're looping. Cool. So we're just going to do num lines is incremented by this. Beautiful. And that means that we can allocate our vertices like this. So we have some sort of like vertex here that we can allocate. You know, we have this many of them. This might be backwards. No, that's right. So this is our vertex buffer data. Why are you pronouncing contours so weirdly? Yeah, sorry, contours. Contours. Yeah, I've been putting weird emphasis for the past like several days, so I think he's just commenting on that. Okay. So for each we probably want to do something like I guess if we do like an array list, we can do something like stood array list of this vertex is going to be initialized with the VB data that we just allocated. Okay. And we can just say for each contour, we push something in here. So it's like for 0 to contour len, we have some index. We have the A position of this thing is what? The A position is contour at I. The B position is contour at I plus 1, but we need to mod this by the contour len. And then we actually fucked this up. So the number of lines here, the number of vertices is number of lines times 2. Right? So then all we have to do is we say VB data append this is the wrong, I don't think we need UV coordinates. So we can just kind of, I think that we have something like XYT program. Beautiful, which is the same thing, just like we have like basically preset vertex shaders that I don't want to write every time, where we have like an XY position and a transform. So we just use those instead. And I believe that, like, what is our vertex type here? What does our, it's probably just vpause, probably. Yep. So we say vpause is A, and then we append B as well. Beautiful. A and B. And if we fail here, then we did some bad math earlier, so that should never fucking happen. Are all Twitch emojis GIFs, or will you need PNG, JPEG, etc. as well? We support PNGs. We do not support JPEG, but also they are all GIFs. We checked. Why can't I clear that selection? There we go. Okay, so this should give us all the lines that we need. And so we should be able to say, okay, our render source is going to be backed by this data. Beautiful. And then we are going to save this stuff for rendering later. Okay, so we're gonna say, we do have a transform. We do not care about color right now. Our fragment shader is literally just gonna output a white line, I think. Cool. We don't have UV input. We don't have this. This is literally the world's simplest fragment shader. And then our render is literally just like self program render transform. Boom. All of this stuff goes away probably. Beautiful. And let's see what happens here. Expect to type right, wrong way. I'm sorry, sir. Sorry to piss you off. I will use the right types next time. Okay, this thing is mad because this can't fail. So true. We do allocate, which means that these need to be tried. Like this. Okay, this guy's pissed because I guess he's probably doesn't really understand the type here. So maybe that will make him happier. Yep. Okay, there you go, sir. Chill the fuck out. This guy's mad because he's like, excuse me, you need to pass in our scratch allocator. So true. Here you go, sir. Have a good day. This guy's mad because we have to actually turn this into a vertex buffer. So VB is going to be some sort of buffer. So we're going to have a buffer here that's going to be attached to whatever allocator that we are using this thing on. And he is going to have VB data here. And then we have the vertex buffer gets passed here. Beautiful. He is pissed probably because it has to be tried. And I probably misspelled make there. Program here is like, sir, I want XYT program, not XYUVT program. Beautiful. This hover state is dead. And do we see something? Good news. We see some triangle. We see a triangle, but that's not really what we want. We want lines. So we want to be render lines here. Okay, there we go. Good news. Good news. That is working. We have our widget rendering these things. Can we do a little, you know, increase the line width here? And then can we also increase the size of the widget? You know, be a little bigger. Beautiful. Beautiful. Beautiful, beautiful, beautiful. So, we probably also want to render the vertices, right? So maybe this is going to be the line render source, and we're going to have the vertex render source as well. And our vertex, this is now line render source here. And then we're going to have our vertex render source is going to be very similar, except this is the, I guess, the line data now. And this is line data list. And then we are also going to have vertex data. So here, vertex data is, I guess, just the number of lines that we have. I think that is the same, I think. And then vertex data list, again, because I'm too lazy to track the indexes myself. And then for each contour, we do vertex data list append bounded with just A. Easy peasy. Vertex render source is something like this. We have vertex render data or buffer, I guess, is something that looks like this. And we use vertex data here, bang, bang, boom. So we have line render source here and S line vertex. Cool, easy peasy. I think we forgot to bind the data here. Here we go, vertex render source gets bound the data from the vertex render buffer. And we should be able to do a little GL pointies, right? We should be able to go render points here with the vertex render source, and then we have the line render source. Okay. Can we do like GL point size 10 or something? Okay. Beautiful. And then let's render the vertices in a different color. So let's make it so that our fragment shader has a color input, uniform vec3 color maybe, and then we'll go like this. And then we have to say, excuse me, sir, we would like to pass a color into this guy. We have a little bit of like Zig reflection magic to automatically pass this stuff into the OpenGL stuff. So now we should just be able to be like, 1, 1, 1 to make it white for the lines, and let's do green for the points. Beautiful. Beautiful! We could actually make the vertices even bigger. There we go. There we go. Okay, cool. So here is our test case. And we now need to basically merge these things together. So what we're hoping to see is we come up with something where we can shove points on here instead, right? So I think we need to define some sort of graph structure, right? We want to define some sort of, I guess we're going to have some sort of like contour merger, right? And I assume that we're going to want to like visualize the steps of this thing as we're debugging it, right? So we're going to have some sort of like thing that we're doing incrementally, I would guess, right? Is that true? I mean, I know that we're looping over each. We said we were going to go contour by contour and add them in, probably, right? Like, what is like the chain of operations here? We take our first contour, we slap them in there, right? We are assuming no overlapping of individual contours, of a contour with itself. Then, what? We have this second contour. And we are going to check intersections, I guess, with the existing contour. And then what happens when we add a third contour? So I guess we only check each contour's intersections with all of the contours before it, right? Because like if I were to check contour 1, if the square is contour 1 and the diamond's contour 2, if I were to check 1 against 2 and then 2 against 1 again, we would like double split probably. So probably we check contour 2 against 1, 1 against no one, and then if we have contour 3, we check contour 3 against contours 1 and 2, right? And so we will kind of split these vertices here. These are all going to go onto one graph, I think, right? So I guess we're going to have some sort of like push contour, right? And I assume that like we are going to have something that we have nodes and edges. Do we want to store like vertices separate from edges? Or is it that we only need to store edges because the vertices are kind of implicit? I feel like the vertices are implicit. No, because like the thing is after merging, so in this case where we have the split case, right? Where this is counterclockwise and this is clockwise, where, you know, the end state is that this gets filled in and this gets filled in and this is empty. We are going to have vertices that have like multiple edges coming out of them, right? I guess a question is, do we care if we duplicate vertices here? Like, what is like the ideal thing that happens here? So we do our first contour, this guy comes in, and we split him with this guy, right? So I guess the initial state is just that we have 1, 2, 3, 4, 5, 6 vertices here. And we are eventually going to purge none of these. All of these vertices are going to stay. If it was a clockwise one, then we would purge this line, and this line, and this line, and this line. is what we would end up purging. But I guess, like, I think what we are ending up with here is a bunch of independent edges. I think all we care about is edges here. The only reason that you would want to store your vertices separately is to deduplicate them. Right? So, like, technically, you know, if we were to store each of our edges independently, we have to store this vertex twice, this vertex twice, this vertex twice, this vertex twice, this vertex 4 times. By having your vertices as their own thing in the list, then you deduplicate that. So I suspect that that's the right play, right? You can kind of have like vertices here is going to be a mutable thing, right? We are going to be appending to this list of vec2s, probably, right? And our edges, I think we are going to have some sort of edge, which is a structure which has, you know, A from some vertex, which we can store like kind of low resolution. Like, we're not going to have more than this many in like vertices in a graph, probably. We can maybe update this later, but for now we can kind of get away with like using up less space by doing this. Right? Easy. So, when we push a contour to the graph, what are we doing? I guess before we do anything intelligent, I guess this guy probably needs an allocator, right? We are going to this is giving me PTSD and reminding me of geometry pipelines of the late 90s. Why are you using anything other than triangles? Because I'm too stupid to triangulate meshes. I'm too stupid to triangulate arbitrary contours. That's why. I looked up arbitrary polygon triangulation, and it looked not easy. But you are right. That would be nice. But I also think that the distance field stuff is not necessarily easier once you get into that. But I agree. To some extent. Okay, before we do anything intelligent, I guess it's literally the things that we're doing in our render thing are what is very similar, right? Why is all of our syntax highlighted, by the way? Because I accidentally pasted something in here. That's funny. Okay. So it's the same thing, right? So we have we take the contour for each vertex in the contour. We are pushing the vertex here. And I guess we have like start index here. Probably something like this. Vert start is vertices len here. And then we're gonna do like edges append. You know, A is vert start plus I, and B is vert start plus I plus 1 mod the contour len. Something like this, I believe. That sounds kind of right. This is the easy option. In my head, yeah, this is the option I can understand. It's easier to reason about quads in your head, which is the most important part when fucking around with something you only kind of understand. True, but I don't think we're working with quads either. We're working with lines. I can understand lines. We aren't advanced enough around here to use 2D shapes yet. Okay, cool. So now instead of doing whatever the fuck we're doing here, I would rather render the graph. Right? So this is the merger. Right? And I guess we now don't have to do any of this stuff here. We are still gonna have our line and vertex render sources, but our line data is literally gonna, I guess it's like This is going to be... we're gonna allocate some sort of like merge, like something related to the merger edges. But this is gonna be of R times 2, like before. But the type is a vector 2, right? And I guess we're gonna go for each edge. We are going to... I guess we're going to have our like line data list as well here, like we had before, which is just like a stood array list of this thing backed by this buffer. We're going to do something like we're going to index into the merger vertices at edge A and edge B. And this is our line that we're adding. Only like one at a time though. But yeah, like this. And this is append bounded, catch unreachable like before. Beautiful. And then we are going to render the vertices as well. So our vertex data is something. I don't know yet. Vertices len here. And it's literally just like append bounded the vertex. I don't know. There we go. Something like that. Something like that. This is mad now. So now we make our merger. Is our contour merger. We're gonna use our root allocator, fuck it. We are going to have vertices start at nothing, edges start at nothing, and we're gonna go merger, push contour box, and push contour diamond. And then we can kind of initialize this thing with the merger. And if everyone's happy, then we'll be happy. What is this mad about? Expected 2 arguments, found 1. True. True. We need to append this with some allocator. This guy's mad because we need to int cast these because we were trying to cheat and store them lower resolution. This is mad because this should be items. So true. This should be tried because we're allocating. True. This thing needs to be variable because we are modifying the count. This guy is mad because vector 2 does not support struct initialization syntax. True. This would be like this. Wait, what am I looking at? No, I'm confused. I don't know what I'm looking at here. So vector 2 does not support struct. Oh, because this should be a vertex. We are doing vertices here, not vectors. True, which are very similar, but the type is important here. Alright, is that better? Now he's pissed because append bounded here. Oopies. Alright, what's happening here? Items here. Vertex data is mad because I didn't write try here. Again, oopies. And then, what's he pissed about? Var here. There we go. Does it work? Oopsies. We are still alive, so it looks like everything's working. Okay. So, I guess now what we want to do is we want to start getting these vertices in here, right? So every time we push a contour, we push these edges, and maybe... So what's kind of interesting here is it's better to check against the original contours, which is kind of interesting, right? Like if I do this and then this, without some sort of like intelligent spatial thing, we are going to at some point, like to calculate these crosses. Oh no, we do. I was gonna say that we want to compare against the original thing. Maybe that's still true. I'm thinking. So, yeah, anywhere we cross somewhere, we're gonna add a vertex. We might want to decimate our vertices later, such that like any vertices that are too close to each other get like merged into one. But for now, I think we just add one for any cross. And so, if that is the case, we are always adding one per cross, then there's less comparisons to do if we compare with the original contours, not the split ones in the graph. Right? Just because there's like less comparisons. Because we're going to be comparing every edge that we add with every edge that we've previously seen. Yeah. No, okay, but we are splitting this edge here. So we do need to know the edges that are currently in the graph. Okay. So we say for each edge in our contour that we're adding, let us intersection test this thing with all of the previous edges, all of the other edges that are in our graph right now. So line intersection. How do we do this? It's like we have some start and end. This is on line A. We have some start and end on line B, right? You can express this line as like, you know, start plus some sort of like interpolation value, times the direction, right? Where direction is kind of like this vector. And then you can kind of have like B start plus another interpolation times direction. And you're looking for the case where these two things are equal to each other, right? So you have like A start plus T times A dir equals B start plus another interpolation variable U times B dir. And then you actually have this looks like one equation, two unknowns, right? Where you're trying to find T, where T and U, like the values of T and U for this equality. But keep in mind that this is actually two equations because you have like the x-axis and the y-axis component for each one. I'm not going to do that math because I'm too lazy. But if you just look up line intersection, somebody will give us the answer. So it's probably this one, right? This is the same thing, right? So they have x1, y1 plus t times the distance, or like the direction, x3, y3. Okay. Yep, and then they do a bunch of substitutions. And here we get the t value for the t interpolation, the u value for the u interpolation. And if both t and u are in the correct range of 0 to 1, then we are within the line. Perfect. Okay. So can we just copy paste this? Is that gonna work? Line intersection, which is gonna return an optional point probably? No. Okay. Well, fuck me. I guess. T is x1 minus x3 times y3 minus y4 minus y1 minus y3 times x3 minus x4. Right? Is that right? X1, X3, Y3, Y4, Y1, Y3, X3, X4. Beautiful. So this is all on top of something, which is X1 minus X2 times Y3 minus Y4 minus Y1 minus Y2 times X3 minus X4. Boom. And then U is negative x1 minus x2 times y1 minus y3 minus y1 minus y2 times x1 minus x3. Okay. Then we have on the bottom x1, x2, y3, y4 minus y1 minus y2 times x3 minus x4. Same denominator. So, which means that we can kind of yoink this out like this. Okay, and then we need to define our x1, x2, x3, x4. So let's define a line. I guess we can kind of do this within the contour merger, and then we can kind of define our lines as like edges. Yeah. A, B. And which means that we have, you know, what is our x1, x2, x3, x4? So x1, x2 is x1 here is the start point of edge A. So we need self here. So this is going to be the start of A. Y1 is the Y value of this thing, which means X2 and Y2 are the end points of this edge. And then 3 and 4 are all from B. I think that's right? So they have X3 is the start point of line 2, Y3 is the start point of line 2. Beautiful. And then X4 and Y4 are the endpoints. Beautiful. Okay, so if t is greater than 1 or t is less than 0, return null. Same with u. We have some problems here with if we go through vertex, I think we double count. But we'll deal with that later. And maybe that's fine. We'll just double split. Maybe that's okay. This might come up later as a problem. Okay. So then I guess we turn the intersection point at this point, right? So then we have T and U. So it's like I think we only need one of them, right? Because it's going to be on one of the lines. So we can just kind of do like a stud math lerp of, you know, vertices, items A and B, right? So like the 2 points along this line, and we are lerping by T. Right, because T was for line 1? Yes, it was. Beautiful. And we might need to splat T here. Okay, so for each edge now, we are going to check if this intersects. So let's start by just adding vertices if we intersect, and then we will adjust our edges afterwards. So if, I guess we go for each of the existing edges. Existing. So this is this guy. So our edge is an edge that looks like this, which means that this guy is just like, here's the edge. And before we do any insertion of edges, probably we check if there's an intersection between the existing edge and the new edge. If that is true, we append a new vertex at that location. That seems right. That seems kind of right. Splat must have a no result type. Do I need to do like a vec2 here? There we go. Oh, let's fucking go, baby. Those are all our verts. But these lines are wrong now because these lines are not segmenting those vertexes, right? So how do we make sure that this is correct visually? We probably want to color each line differently, right? That'll give us a clue, probably. So can we do like PRNG is stud random default random number generator. We don't really care about this thing being seeded anything reasonable. We can just seed it 0. We have rand. The interface to this thing is PRNG get me the random interface. And I think that we just kind of want a random color for each line, right? So we're going to be like rand dot float. And I assume, is this going to give me 0 to 1 or what? Yep. But I kind of want to clamp the range because I don't want it to be too dark, probably. So can we do like I guess we do rand float. But we add 1 and then divide by 2. So that'll give us in the range 0.5 to 1 instead of 0 to 1. I think. That sounds kind of right. So this will give us 0 to 2. No, this will give us 1 to 2 divided by 2, just 0.5 to 1. Beautiful. Not working, huh? Not working. Why are they all gray? Hello? Can we do this? Oh! Because this is rendering the same color for all lines. I want a color per line. Fuck. Which means that we want, like, vertex data on the lines, probably. Huh? Which means that we probably want a custom... Can we render line by line instead? Is that a thing you can do? GL... render lines or something. How do you do this? OpenGL... GL render... What is it? Draw rays? Can I, like, just say, like, start at... You can do first account, yeah. Okay. I mean, our thing doesn't really support this very nicely, but we can hack it for now. How does this work? He does draw rays starting at 0. We can kind of say that our render source here... can we do array offset type here? So we're going to say you can do start and len. And then if we see this type, we have start, we're going to draw arrays with len start, with len len. And then we can kind of just hack this thing and we can say, 402 line render source len. Oh, it doesn't work like that. For each. Does this thing not have like a length field? What is it called? It's called. Oh, I see. Can we look at this? So he's kind of like expected to be an array. So 402 this thing. We have a new render source where we like start with this thing equaling like this, and then we cheat and we say our line source is going to be this is probably over 2, right? Because it's like 2 points per line or something. And can we say that our thing is going to be now an array offset type? So our start is going to be I times 2, and our len here is going to be 2. Render 2 points. And then we render the line with our random color. I think that does what we want. It's like super hacky, but like whatever. Super hacky, but I think this works. Nope. Okay, can we just draw one line really quick? Nope. All right. So we are rendering them all. Oh, because we're not using the new source. Okay, promising. Okay, promising. However, the colors are all too similar. The colors are too similar. So maybe we alternate. Maybe we use a palette. So this is gonna be some, like, you know, list of colors. And I guess we will index into the palette here. Did I spell palette right? Is it 2 L's or 2 ETs? 2 T's. Great. Okay. So this is a stud math vec 3. Maybe randomize hue. Yeah, I just don't want to bother. It's because I don't want to do like the HSV stuff again. Can we just do like color palette generator, maybe? Another thing we can do. Start the generator. Let's go. Can I like have like number of colors? How many colors can I make? Color palette generator. I guess we could just make colors ourselves. Yeah, okay, we'll just fucking fine. 1 0 0 0 1 0 0 0 1. We have 1 1 1. We have probably 1 1 0. Here, this is like a few of them. Right. And maybe that's enough for now. We don't use this rand, so true. Uh-oh, did I delete the wrong thing? Because I was like, fucked. Each of these needs to be in some curly braces. We have colors at home, yeah, exactly. There we go. We don't have enough colors, obviously, right? So, can we do 1 to 0.5? There we go. Good enough for now. Good enough for now. Hi everyone, still following stuff? Yep, you know it, baby. So now the goal is to see these individual line segments with different colors, right? That would be very cool. Very, very cool. So, what is the play here? If we find a line intersection, we replace the existing edge B is equal to the new position. Okay? And then we inject a new line. We can't modify items as we are iterating, I assume. I assume that that's not okay. But it is if we iterate by index instead. Do we need to test the new edges that we're adding? No, right? We know that any new edges that we're adding are from ourselves. What if we cross an edge twice? Is that possible? No, right? So if I have one line and another line, I can't cross twice on the same edge, right? So this is kind of, for each edge of the new contour is where this loop is. We are checking each edge of the old, of the whole graph. You can, not with two individual line segments. If we brought in a Bezier curve, yes. You can cross infinitely many times. Am I stupid? I guess like if they're like parallel and overlapping. Yeah, but we just won't we'll just fix me. Fucked if overlapping. But we should, I guess it's like fix me here, like return null if parallel is probably the play. Just don't allow overlapping edges that way. Okay, so this means that we can only intersect with each edge can only intersect with each edge in the existing graph one time, which means that it's okay to go here, 0 to self edges items len. We have existing is self edges items at I, and then this gets invalidated. Like note here, invalidates reference to existing, but it doesn't matter because but that's okay because it's at the end, and we insert a new edge now. And I guess this only happens if we collided. So existing, we're going from it's like this, right? Existing B. No, we are doing new vert to existing B. I guess this is a new index. Okay. And new vert is mad because we need to cast here. True. Okay. Can we do the int cast here? Oh my god, what's happening? There we go. Also, since we're in discrete world, they can cross at 2 pixels. Yeah. I mean, yeah. We're gonna fix that eventually. Okay, so that's interesting. We are definitely seeing like some of the line segments here, but clearly that's not doing what I expected. Off by one error. So I'm thinking. I overwrote existing.b. Oh, good point. Good point. Good point. There we go. That's a lot better. So now we are seeing that the first square is getting spliced, but the second square is not, right? Because we are inserting that line as is here, which is no longer correct. Right? It's like we need to break this line up as we're inserting it, right? So as we insert, we check all of the intersections, and I guess we insert the new vertices as we go. And then we must have to like sort the vertices that we added along the new axis. Right? Like you could, this is like the way that's obvious in my brain. This might be like stupid, right? But as we add this guy, so we add this line, right? And we see, we have here and here are the 2 points. And then we find like 2 new intersection points, right? Now, these are kind of like checked in arbitrary order. So for us to split this line up before we add it, I think we just sort the vertices that we added in order of this. Do you need to check if the intersection is already an existing vertex? I think no. I think there's no cost here in just adding too many vertices. I think. But maybe we'll find out that's not true later. Yeah, okay. So I think this is okay, right? So we can kind of do something like, we kind of know where like the vertices like started. So we can probably add, oh, we're already tracking this, good. So we know that we added here our 2 vertexes. And then here, we are adding more oh no, this is for the contour, not for the line. Do I use this vert start anywhere? Yes, okay, so this is contour vert start. And then I guess we have like line vert start. So then every time we add a vertex here, it goes to the vertex buffer, the vertices buffer here. So now we can kind of say like, I guess its line vert start is here, actually. So our added vertices is the vertex items from line vert start onwards. Now this might be out of bounds. So if line vert start is less than if it in bounds, then we do this thing, I guess. And then we sort these. Which we can't sort in place, unfortunately, because we've already added references to them here. Which is annoying. It would be nice to be able to sort in place. But what you gonna do? So I guess Instead, uh, we just need a buffer here. You know, intersection point buff. You know, we'll just do this for now. Like, what's like, you know, if there's more than 100 intersections, then we'll update this. But points is it just floating points? No, it's kind of like a pair, right? It's like it's both uh the interpolation value and its vertex position, like its vertex ID. Something like that. So let's just do this for now. So like a little array list that is backed by this buffer. Okay, and when we get this line intersection, he is going to return the interpolation value along A, and then we'll kind of swap the order here. So I guess this is just the same type here, actually. This is just the intersection point here. And he is going to return T with this. There we go. Cool. Cool. Okay, so now this is pause at intersection 1 now, and then we do a little try intersection points append intersection, and then we sort these at the end, probably. So we do something like stud mem sort. We are sorting intersection points in intersection points items or something. Beautiful. And the context is probably void. Yep. Okay. And our sort function is something. What does he want? He wants this. So LHS is an intersection point, RHS is an intersection point, and this is void, context void here, and we're going to do LHS dot 0 is less than LHS 1. Okay, that seems kind of right. That seems kind of right. Headless Hunter, thank you for the raid. What's up, guys? What's up? We probably want RHS here and 0 here. Oops. Okay, so then we have all these intersection points, and instead, well, this should be sorted down here. I guess we probably want to initially add 2 points, right? Because like we are going to throw in the start and the end of the line, I think. Right, so it's like at T0 we have edge A. And edge B. But the type here is wrong now. This intersection point is... This is like a vec2 here. And that means that here we're gonna like... this is like index intersection point or something. What are we doing? Great question. we are trying to merge a bunch of contours into one graph so that we can generate signed distance fields in one shot without having to do multiple passes, because we're trying to render some text for our GUI framework. I wish I could show you right this second, but we have a little bit of compile errors to fix. But hopefully in a second we can kind of show where we're at right now. Error union is ignored. So true. Okay, and then this guy wants to append the the interpolation point as well as the new vert here. This will be a baked operation when loading a font file, calculating contour overlaps, not every render. Not every render, so it will be, but it won't be baked at compilation time because the font file could be loaded at runtime. It's going to be at first addition of each character into the glyph atlas. So like as we see new characters, we like take them and put them into this texture that we sample from later. And so that's when we will do all this work. This is append bounded. Oh fuck. Does that compile? We're close. This is indexed now. Okay. Okay, we compile it so we can show you at least where we're at right now. 2 squares. We are trying to take the 2 overlapping squares, chop them up, find the inside edges. We're still on the chop up step, right? So we've chopped up the first square correctly, but the second square has not been chopped up correctly. We see there's like one contiguous line here. And so we should have that fixed right now. We should be able to go for intersection points. I guess it's like more like 0 to intersection points items or something. We are probably doing len -1 here, probably because I think that we have, we have added we have like these points sorted, so we have 3 edges to add. 1, 2, 3. So we should be able to go like intersection points items J, and this is the second point here, and then we should be able to add that to our edges. So A is A, B is B, and then this guy is J+1. Okay. That feels kind of right. Chop them up. Yeah, hell yeah. Hell yeah, chop those bad boys up. Huh. Still no. I thought that would fix it. Wait, hold on, looking again. Why are some of them right? This line here is chopped up now, right? 1, 2, 3. But these ones are not. I like how the color changes every time. Yeah. Oops. So that's kind of interesting. Am I doing so for each edge that we add? We add the 2 intersection points. We check these things. Yeah, that's surprising. I think you need more colors. Yeah, it could be. I wouldn't be shocked. I wouldn't be shocked if we need more colors. Fine! We'll do a fucking... I don't want to do this work. I don't want to do this work. HSV to RGB. Do the color change reverse out the window? Probably not. What's the formula? This shit, right? Oh my god. I know we did all of this work that one time to project the RGB color cube from the corner, and it's like, HSV is kind of like, you have this like cube, right, of like RGB on each axis, and if you look at the cube like from this corner, then it looks kind of like you get like a hexagon, kind of, right? And if you look at this hexagon where like this is the corner, like this is kind of like the cube like this, HSV is like the hue is kind of like its point on this projection of the cube, but then you kind of like turn it into a circle. So that's why you have this like 0 to this every 60 degrees you do something else type shit. But so like we did the 3D math one time to do it the other way, which I like better. But just permute them, add, multiply, clamp, etc. Yeah, it's fine. We'll just do HSV because I think HSV is like easier to randomize the colors in. I think. Function HSV to RGB. Okay, what are we looking at here? What the fuck is R prime, G prime, and B prime? Oh, those are these. Right. That's the interesting part. I can't paste that. God damn it. Fuck me. CX0. CX0. XC0. We got 0CX. We got 0XC. And then we got. Oh my god. Oh my god. Oh my god. Oh my god. XC0 and C0X. Okay. Let's do a little bit of this. We have some sort of like H input. Probably float. I actually don't know what this looks a lot like. This looks. Oh yeah, HSV. So H is 0 to 360. S is 0 to 1. V is 0 to 1. Got it. This is abs. This is mod here. And this is H over 60. So that's fine. Okay. Easy peasy. Why is this mad? Because this is like this. I think that for mod with floats, you need to do like this instead in this language. And then we have some form of I guess this is a switch, I guess. Segment or something. Okay. So probably something like this. Something like this. Something like this. Then these get like 0, 1, 2, 3, 4, 5, and then we get the segment by doing like is H over 60, right? Yep. Yep. And this is gonna be like a int from float or something. That probably does it. 1, 2, 3, 4, 5, and then we probably want a mod 6 here just in case. Just in case. Alright. Okay. Why is M? What the fuck is M? Oh, we add this to the output. Plus M. Something like this. If you say so. Why does he like this? Because he doesn't know the type here. Okay, he's still pissed, which I don't really get. Maybe like this. Oh, Vec 3, my bad. Okay, so now we should be able to do, when we generate our color palette, can we do HSV to RGB? I don't know. 0 on 1 or something. Let's just start here, and I just want to see if this like kind of works at all. Yep, red. So then we, you know, do like 20-degree increments. Okay, that's promising. Too close though. Maybe 30-degree increments. So we have red, orange, yellow, green in here. Sure, that seems fine. So do I want to be more intelligent? Do I want to be more intelligent here? Probably, right? So const num elms is gonna be can we do these at like different saturation levels? Maybe? And then we probably want to scramble them actually, right? And we want to scramble them according to some rules that like we actually have like the farthest ones away from each other. So maybe we do just do it manually. 30, 60, 90, 120, 150, 180, 210, 24. You know what, you guys? I don't want to fucking hear it. I don't want to fucking hear it, okay? I don't want to fucking hear it. The second last switch is wrong. X0C. True. Which probably wasn't helping. And then we kind of want to do some sort of like rotation here. I don't know what it is, but it's like obviously 0 and 30 shouldn't be next to each other, right? Like these things should be like far away from each other. But I'm too stupid to figure out what the rule is. I guess it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's for 0 to 12. It's like your like index is, you know what? Who fucking cares? Who fucking cares? We'll just do this. We'll desaturate a bunch of them as well. Surely that's enough colors. All right. So we are still seeing, we added all our new colors, and we are still seeing lines that stay consistent. Did I do something stupid, like add to the edge list? Okay, if I just don't add the edges for this thing that we're pushing in, the second guy, I'm hoping to see the diamond go missing. Oh, we're missing everything, of course. Okay. So can I do a little like add edge here? If add edge, we add the edge. Makes sense. Makes sense. Oops. So we add for the box. We do not add for the diamond. Okay. So that is promising to some extent. Right? Like, so the box is cut up correctly. if we switch the order, what happens? So we add the diamond now. He's cut up correctly. But then we add the box in after. And the box's lines are still wrong. So that means that the like intersection points must be wrong, right? It must be. So can we look at intersection points? This must be wrong. I don't know why, but what's wrong? So these boxes have lines that are not chopped up like in some of these. Right? Like this line is chopped up here, but this one isn't, this one isn't, this one isn't. So it's like, why the fuck is that happening? You know what I mean? I'm an idiot, that's why. When we add the edge, this guy needs to be... the interpolation values need to go from 0 to 1, not 0 to 0. That's way better, baby! Let's fucking go! So what was supposed to be happening was I was supposed to be interpolating... I was supposed to be adding... Hold on. I was supposed to be adding for each line 0 and 1 points here that are like A and B. And then as we find crosses, like add like 0.33 with C and 0.66 as point D, right? And I accidentally flagged point B here as 0. So it meant that like when we sorted these guys afterwards, we sorted A and B right next to each other. And then they would overwrite, like we had these line segments, AC and AD or whatever, and CD. But then we also had AB, which was overriding them. So that's much better. Okay. So now all we have to do is find our inside edges. I guess this is kind of just purge inside edges. So, I guess we do something like what is the play here? We take probably the midpoint of the edge and raycast it outwards. Then we count how many lines we intersect with. And well, actually, because this is like like going through a vertex is a degenerate case, I'm actually going to raycast horizontally every time just to dodge the case of trying to go through a vertex. I mean, we'll hit it here, but that's okay. Yeah. That's fine. Okay. So we are going to, oopsies, raycast out from the center of each edge to the nearest horizontal side. I guess it can just go right. We can just go right every time. Fuck it. We go right every time. And we check how many times we intersect with lines that are pointing down or up. Okay. Then, if the count is 0, so here we'll find one that goes down, one that goes up. Or sorry, these are both clockwise. So this is going to hit 2 down. This guy's going to hit 1 down, 2 down. Which means that this is a non-zero edge, I think. And so anything that is not a zero edge gets deleted. So this guy will hit 1 up, 1 down, 1 down, but he's an up edge. Right? So we check our edge value, which is going to be 1. then this becomes 2, 1, 0. Perfect. Perfect. Okay. So here we want to do purge edges. So he's going to go for each of my edges. I guess we're going to go for 0 to self. If we go backwards, does that make our lives easier? It might. Because then we can pop things as we find them. Yeah, I think that makes sense. Var I is self edges items len. While I is greater than 0, we decrement I by 1, and then we use that to index it to here. If so I guess we say we're doing an n squared search now, which is fucking stupid. But we'll figure that out later. We only have to check. So I guess we like generate the like raycast is going to be we're gonna start. I guess we want like the center point. So I guess it's like vertices at edge A. And then we have B is this. Okay. So the center is A plus B over 2. Okay. And so then our ray that we're casting is a line which has A at position center and B at like as far to the right as we could possibly get. Yeah. So can we just get like, you know, fix me, pick something way more sane. In fact, we know right now everything is between 0 and 1, so we'll just do this. Now, we don't have a line type right now. Our line intersection test is kind of done using our edges in the graph. So let's pull this out, I guess. Let's pull this out. And this is going to be a line now. So he's just going to have like A is a point and B is a point. Okay, so this is going to be your intersection point is chill still. This guy's going to work on lines. So this is no longer like this. This is I guess it's just this, right? You just delete this part. I think that makes sense. And then our internal line intersection, like we'll call this edge intersection now. And we are literally just going to construct our lines out of our edges, right? So we're going to say like a line is a line that has A is A, but from self vertices items. B is from AB, and then B line just is like use B here, and then we can return line intersection with A line and B line. Okay, that seems like it kind of works. That seems like it kind of works. Yep. Cool. This is now like this. And now we can do line intersection here. So we can use the ray. And so for each edge in this thing that is not me, I guess, right? So we're looking at each edge in the graph. And so I guess we go for 0 to self edges items len j, if I is equal to j, continue. And then we're going to do like a line intersection with our ray and the other edge. Like other line is other edge, I guess, is self edges items at j. We have our other line is this thing converted, so we have self it's like a line that has its a at other edge a vertices like this, and b is b. Okay, so we can check if we intersect with the other line. And if we intersect with the other line, then we adjust our count, right? So if our count is it's like our edge. It's like, I guess it depends on the vertex. So I guess like we have a y minus by. So a is the start, b is the end. So we probably want to do b minus a. So we're gonna say like edge dir is this. If edge dir is like below some tolerance, we probably just continue. Like, we just don't remove any horizontal edges, probably. I don't know. Epsilon stuff is probably messed up. But otherwise, we're good to go. So then we kind of have our, like, edge dir. If edge dir is greater than 0, our count starts at 1. Otherwise, it starts at -1. Okay. This is an I32 probably, actually. And if we intersect, anytime our ray intersects a line going to the right, abs is the wrong bracket. True. True. We're gonna do like count plus equals other edge dir. You know, it's kind of the same thing. So can we do like a little function that's like edge dir to increment, which is gonna be, I guess, a line? No, we're gonna say like AY BY, and this is gonna return either two, I guess. So a BY minus AY, if this is greater than 0, return. I guess this is like an optional, right? So then we can do the epsilon check in here as well. So we can kind of do all of this stuff, right? We can do like edge dir is BY minus AY. This is a return null here. And then we can do like if edge dir is greater than 0, 1 else 0, right? Then all of this stuff is like we can initialize count here with edge dir to increment of B1 or A1 B1, I guess. Or else continue. Okay. So that gets this stuff out of the way. And then if we intersect, we do edge dir to increment with other line A1, other line B1. That seems kind of right. If count is greater than 0, or is not equal to 0, we purge it, right? So we do... Well, for now, let's just ignore the count for a second. Because I think that we refactored some stuff, and there's like a good chance that we fucked it up. Right, so let's just make sure that everything else is still chilling, you know what I mean? Okay. Okay, so this is all still good. Our little star is still chilling. And now can we just purge lines? So if count is not equal to 0, we do self, edges, swap, remove, I. Probably, right? Probably. Interesting. We're not calling the function. That would do it, right? You have to call a function if you want to fucking run it. God, why do they always do this to me? You know? Why do they always do this to me? Alright, now he's fucking pissed. Because at 182, we probably need to do this as like a vec2. Splat out this 2.0 or something. Where's that mad at? Some 2.0 somewhere at 186. So we kind of want to use the center X position or center Y position, but throw X over to the side. Edge dir to increment down here. What happens if the line is horizontal? I think that can't happen here because this guy is supposed to get mad if they're parallel. So that can happen right now, but we just should say like if A dot B, like A vec is going to be A dot B minus A dot A, and then B vec is going to be B dot B minus B dot A, and then we probably want to normalize these. And then if A vec, you know, if these are like aligned, so we do like the dot product of A of B. If this is like greater than, you know, 99, but a bitch ain't one, we give up. Is this still the Twitch client or the compositor? Twitch client. We are still on the Twitch client. Okay. If edge dir, oh, he's mad about like some sort of comp time bullshit. So I guess if we return, that'll sort it out. He is mad about our unreachable at 207. So we are hitting a case where this guy is saying that my edge direction is... Oh, no, sorry. Oh, yeah. So this is saying we have, like... Oh, maybe the dot product needs to check if positive or negative one. Like, absolute. Because they could be opposite directions. Still mad, huh? This shouldn't happen. Because ray should be horizontal. Which means that this should not intersect with anything unless it is... if it is also horizontal. So we have a problem. Can we... Uh-oh. And can we print out maybe ray and other line? I assume that these are like parallel lines, right? So we have y0 twice here and then y0 twice here. So y, then, is this line intersection passing, right? Because these guys should be aligned. Right? Yes. Oh, interesting. Wait. These can't be aligned because A and B here, it's like a zero length line. Why are there zero length lines in here at all? That's not good. That's not good at all. Like, what the fuck? Why is there a zero? Can we, I don't know. Let's just kind of dump out what we get after we push the contours. Uh, this is not helpful. This is not helpful. Not helpful at all. Well, for now, I'm just gonna cheat and say, if avec, I guess we kind of want to do, maybe we do the subtraction first. And maybe we do stud math normalize here. And here, and then we sec if a vec len is less than, you know, eps or something, return null. For now, this is a hack. But it's good enough for now. Okay. So we're idiots here. And we do have to check these edges, which is good, which is not good. And then we're also purging too many, which is interesting, right? So that's not good. That's not good. We are purging every single thing on the left here. Yeah, I guess we did something wrong here, right? So if we're casting to the right here, oh, did we do something stupid, by the way? Yeah, this should be else -1. Okay, that's closer to being sane. But we have made a mistake here, right? So I think that we want to, how do I say this? Okay, so if we are on an upwards line and we are heading right, we should start at 1. But if we are on a downwards line and we're heading right, we should start at 0. Because this is us leaving and this is us entering, which means that we're expecting to find an equivalent downward stroke here. So it's more like if count is equal to -1, count is equal to 0 for our initialization case. Close. Close. We are getting something that looks a little bit sane now. Right? Like, no, I mean, this is insane. This does not look reasonable at all. This does not look reasonable in the slightest. So, can we inspect an individual line here? Oh, fuck me. We're removing lines as we're doing the walking. So that doesn't work. That doesn't work because we need to not remove any edges until we've checked all of the edges to remove. So, because like the winding count relies on all the edges being there. I kind of want like original contours in here. And then we can just compare against the original contours, which means less comparisons in general, and also they won't get like removed as we go, which kind of fixes a bunch of problems at once. Okay, so now when we are doing our comparisons, we do not compare against our edges, we compare against the original contours. Uh, so we're gonna say contour here, and for 0 to contour len, we are looking at index j. Yeah, that seems fine. So then our other line is point A is contour J. B is contour J plus 1, but mod contour len. And then we can do our line intersection that way. Original contours does need to get set when we construct this thing. So original contours is an empty vector by default. And we do need to write try when we append to that thing. So true, dude. For items in here. Okay. That is obviously fucking broken still. Obviously still broken. So can we pick an individual one? I mean, I guess it's pretty clear that like we probably have like a count initialization problem. I want to like find a specific edge and like debug that. You know what I mean? So can we like let's look for the edge where B is the top left, right? If B minus the top left corner, so this is negative 0.5, negative 0.5. If this is near 0, you know, something like this. Log is false, log is true, and then here we can do like if log is true, can we find our intersections? Stood debug print collided at this location. Something like this. He is mad about something here. I missed a bracket. Okay. So first of all, does log ever get to be true here? Does this ever hit? This does get hit a couple times, which is interesting. Which is interesting. I mean, the fact that this hits twice is crazy, right? The fact that it hits twice is a bug. Right? Because that means that there must be two lines where this is hitting. So is this, if log... can we log what, like, the edge is? A is this. B is this. Like, what is happening? What the fuck is happening? So one of these edges is coming from... One of these edges is 0 length. And then the other one's coming from... X negative 0.2... Whoa. Shouldn't one of them be coming from here? Oh, negative is down here. I want negative positive. Hold on. Okay, so one of them... So there are two 0 length vectors here, which is probably a mistake somewhere. But then we have one where we are at 0.207 here. So it's this line, this one here. Okay, so then this guy's getting collisions, right? We have 4 collisions. 1, 2, 3. We should have one here, and one here. So where's the fourth one coming from? Collided at negative 0.5, 0.35. Oh, he's colliding with himself. He's colliding with himself. Which should not be happening. Maybe we should say who we're colliding with. Collided with this at this. Okay. So we have our line is from this point to this point, right? 0.2 to 0.5, right? Then he collides with... The full line's still there. Oh, sure. So he's colliding with the line from the original at this point. So why is he not rejecting this thing? Can we look at the dot product here? I mean, maybe that our threshold is too low? I mean, the dot product is 1 here. Oh, no, wait. Dot 0. Am I stupid? Am I stupid? Why is this... So dot 0 collided. So that what should this not be... Hold on. A vec this, B vec this. So we should see both of these guys pointing like straight up if this is working the way I expect it to. Okay, so where is our collided here? So oh fuck. Our ray is going sideways. Oh shit, fuck. So of course this won't trigger here. So here we need to check if our lines are perpendicular. If our ray perfectly is perpendicular with the line, well, even that's fine. We just don't want to count ourselves. So if we want to do something like if our edge, if edge is parallel, if edge comes from contour or something, right? Then we don't want to count this one. This is our problem. This is our problem. Yeah, let's do this. Okay. Edge comes from contour. So we have A is a point. B is a point. We have not from contour. From contour line. Oh, this is so fucking hard. We're just not... Okay, here's what we're gonna do. Fuck this optimization where we try to use the original contours. Can we just, like, write down which edges to remove? Oh, but... oh, this is so fucking annoying. Okay. Hold on. So instead of using the original contours, the problem is, I have like an edge segment here, right? And he has come from this larger edge, right? We were trying to do this optimization where we compare against the original contours, but we're like triggering on ourselves here, right? So we could check if the intersection point is super close. Oh yeah, let's just do that. Wait. Let's just do that. Wait, hold on. We're chill. Everything works. We're fine. If our intersection point is really fucking close to our center point, then we freak out. If the length of the intersection point is really close to center point, continue. There we go. Is that better? Let's fucking go! Let's fucking go, baby! So the only problem now is these horizontal lines can't raycast horizontally. Right? They can't raycast horizontally. So can we just do 2 rays? So if line intersection, we'll say like pause is line intersection ray with other line, or else line intersection ray 2 with other line. And then we can use pause here. And then I think that should work. Fuck. Oh, fuck me. Because now edge dir to increment depends on, we need to check, like, We had to use like index 0. Uh, yeah. Edge dir index is 0. So we'll do this. If pause opt is null, we do edge dir index is 0 now. We flip them. And then we use rate 2. Okay. I think that does the right thing. And then here... Wait, hold on. This ray depends on the edge, which we know the edge... we should check if the edge is horizontal just here. Cause yeah. We don't have to we don't have to raycast twice because we just know whether or not we should be casting up or right. Yeah. Okay. So like if B1 minus A1 is less than 0. I don't know. So is like really close. We do ray.b is center 0, 2.0. And edge like anchor index is 0 or something. And then we say like anchor index is 1. And then everywhere we have a 1 in here, we do like anchor index like this, like this, like this, and like this. And I think that should do the right thing. Fuck me. He needs to know what he is. Fuck me. Perfect. Perfect. Why is he mad? Why is he mad? If this thing is abs. Okay, now all of the vertical lines are broken, or all the horizontal lines are broken. So we're doing like something that we're doing here is wrong. Edge dir to increment is doing something. He's checking the right minus the left. If maybe if we flip the direction here, does that kind of fix it? Let's fucking go! Let's fucking go! Okay, so now we can try some other test cases. Okay, let's do a counterclockwise box sitting on the right side of something. Oh, so like clockwise box here, counterclockwise box here, which should result in a area here empty, area here filled. That's what we're hoping for. Actually, first let's just do the one inside. No, it's fine. We'll do this. So this is gonna be like 0.25, 0.75 probably ish. So, and then this is negative 0.25. Sorry. This is 2.5 here as well. All of these are 7.5 in X, 2.5 in Y. Yes. So top left, or let's start at top right. 0.75X, 0.25Y. Then we have counterclockwise, so 0.25 in X, 0.25Y. Then we go bottom left, which is negative 0.25 here, and then 0.75 here. Okay. So we have make box 2, and we say fuck the diamond, And we have 2 boxes now. Okay. Promising to some extent. I think it's probably the initialization. There's something about the, like, original direction. Like, the original count probably depends on the direction of the initial vector. Right? So, like, when we're purging edges, our edge data increment, I mean, he's using the direction of this thing. It's probably that we want to cast left if we're a counterclockwise item versus right if we're a clockwise item. Or something like that. Like, the raycast direction probably depends on the winding order. Yeah, I'm not 100% sure. Not 100% sure. We are at 2 hours and 20 minutes. So I think we kind of come back tomorrow to, like, clean. I'll do some cleanup in happy hour tomorrow, and we can come back and try to sort out the second half of this thing. I think we are close. Right? We're close. And we can do, like, the fill stuff afterwards as well tomorrow. But yeah, we got pretty far today. Happy with that progress. Happy with that. A line going down can either be clockwise on the right or counterclockwise on the left. So I don't know if you can just cast and see what direction the intersection is, but also I don't know what I'm talking about. Yeah, I'm sure that there's some sort of, like, dot product, like some sort of, like, vector math that makes it so that I don't have to care about the direction. I'm sure there's something there. Like, we just take the initial vector and like, cast it perpendicular to the line or something is probably easier than what we're doing. And then also, we also have to sort out, if we go through a vertex, I think it's fucking broken as well. So, more work to do tomorrow. More work to do. But we're close. Thanks for watching, guys. If you like what we saw, we stream most days. We aim for 12:30 to 4 o'clock Pacific time. It's 3 now. You know, it depends on if we have the, like, pre-game segment, which is, like, you know, stuff that's less structured, less titleable, less thumbnailable, less YouTubeable. The stuff that we do not upload to YouTube goes on Patreon, YouTube member, or Twitch VODs. Or you can catch it live. If you don't catch it live, if you pay in the appropriate spot, you get access to the VODs and stuff if we don't post. So if you want that, feel free. No pressure. It is daylight savings time now, by the way. So if you guys are in Europe and your daylight savings time does not, like, line up with ours or wherever the fuck, like, if you're just, like, not in North America, the streams are an hour earlier now. I think. Yes, an hour earlier. So I don't really know how that lines up. I think that's it. Thanks for watching. Peace out. Twitch, let's find someone to raid.